Okay, final learning target of the chapter here, okay? And we've covered a lot of stuff in this learning target, okay, or in this chapter. We learned how to write algebraic expressions for real world situations. Maybe the product of 5 and p would be 5p. You learned how to use order of operations with numerical expressions. You already knew that. You learned how to evaluate. Those were all review. I'd say these two were review, a lot of review. This one, it's maybe a little bit of review. Where it really became new is on these ones here. This is where it really got cranked up. Being able to identify variables, terms, like terms, coefficients, and constants. Okay. Then we got to 6, and again, that was kind of review. Okay, we learned about expanding, and then we learned about factoring for equivalent, to make equivalent expressions. Okay. Now we're going to be able to identify when two expressions are equivalent. This is pretty easy. Okay. That's why I saved it for last. Easiest for last is how I like to do things. So let's see how we do. Go ahead and flip to page number, I want to say 17, something like that. Yes, this is it right here. 18. Learn, it's the very, very back of your thing. Okay? All right, now, I got a lot of questions on here. Okay? A lot of questions we can work on, so please pay attention, okay? There's a lot of, this reviews a lot of learning of chapter 7 right here. I mean, because it all boils down to this. I mean, it all comes back to this. I mean, you'll see what I mean here in a minute. Okay, for instance, it says state whether each pair of expressions are equivalent. So you have to tell me if these two are equivalent. Well, in order to tell me if they're equivalent, you got to know learning target number 5, which is combining like terms. Okay, here you have 3a. Let's say a stands for apples. So let's combine like terms there. What would that equal right there? I have 1 apple, 1 apple, 1 apple. That would be 3 apples. Are they equivalent? Absolutely equivalent. Okay? Let's keep going. I have horses. H equals horses. Worked out well. Okay? I have 2 horses, and I'm adding another 2 horses from somebody else. How many horses do I have now? I have 4 horses. Are they equal? Absolutely yes. Okay? Here we go. I have 2k plus 5. Okay, so now we have to combine like terms. I see like terms k and k. Real quick, before I go on, just so you guys know, just to review a little bit, we understand that this isn't 7k, right? This is wrong. You cannot combine kangaroos, and then this is just a constant right here. So you can't combine those together. This is as simplest as it gets. Whereas this one over here, you can. So we have 2k, 2 kangaroos, 1 kangaroo and 1 kangaroo, and we're multiplying it by 5 constants. Are those the same thing there? Absolutely no, because this is multiplying by 5, this is adding 5. Okay. Oh, and one more way you could always check this, if you wanted to, it's an option. Just say k equals 4. You could check it like that too. And then if you plug it in, see if it gives you the same value. Okay, let's do it. 2 times 4 is 8. Plus 5 would give us 13 there. 4 plus 4 is 8. Times 5 would give us 40. Are those equal? Absolutely not. Whereas this one up here, if we said h, let's just say h equals 3. We have 2 times 3 is 6. 2 times 3 plus 6. That equals 12, right? We take 3 and plug it in here. 4 times 3 equals 12, right? So you can see that they are equivalent. Okay, 13. Now we got to see if these are equivalent. So we take our 6 z's. We got 6 zebras and we got 4 zebras. We now have 10 zebras. How many zebras do we have over here? Do we have 12 zebras? No. You can't combine constants and a variable. So these are absolutely not. Because just because that says 10 doesn't mean anything. I have 10 zebras over here. I have 2 zebras over here. And I have some constants. So these are absolutely not equivalent. Okay, you guys go ahead and try number 14 and 15 for me, please. Okay, here we go. One porcupine and 3 porcupines. How many porcupines do we have? We have 4 porcupines. Are those the same? Absolutely no. Okay, here. Let's see if there's anything that I can combine. I got a 3n, I got a 4n. Okay, so I look here and I go, okay, how many n's do I have? How many n's do I have? I would have 7 n's, and I'd be adding on two constants. Are those the same? Absolutely yes. Why? Because of the commutative property of addition. Commutative property. Those are the exact same thing. Remember, 4 plus 3 is the same as 3 plus 4. That's the same thing. Okay? State whether the two are equivalent. Guys, I hope nobody thinks yes on this one. Why is this not equivalent? Because there is no commutative property of subtraction. You cannot just pick a number. Pick 1. Plug in 1 for f and 1 for f. What's 1 minus 6? Hopefully you guys know it's negative 5 because you have 1, you're taking away 6. So now you're negative $5 or whatever. And over here you're doing 6 minus 1, that equals positive 5. Those are not even close. They're a completely different answer. Just because it's the same number part means nothing. I'm sure if I asked you guys if you'd rather have negative 5 or positive $5, you'd all say positive $5. You're not even close to being the same thing. Let's check this one. 5c minus 5c and a minus a, are those equivalent? Think about it. I'll give you a couple seconds just to think. These are absolutely equal. Because I can tell you, I don't even need to know c or a or anything to know that that's 0. Because I know if I have 5 cheetahs and I subtract 5 cheetahs, I got 0 cheetahs left. There is no cheetahs left at all. Over here, if I have an apple on my desk and I take away an apple, I now have 0. Okay? So yes, those are absolutely equivalent. Okay? Okay, now we're going to get a little bit more challenging. A little bit, not a ton harder. Okay? Here we go. We have 5x. Okay, let's go over here. Let's go over here and look and say, let's see if this thing equals 5x. I have 1x, I have another x, and I have 3 x's. How many x's do I have in total? 5x. So these are absolutely yes. They are equivalent. Okay? Here, we got to combine like terms. Those are all like because they're all y's. There's a like term, there's a like term, there's a like term. And then those two are like each other. Okay? So I have 4 yo-yos. I'm adding 2 yo-yos and 1 yo-yo. That means I have 7y. Over here, and over here I have 5 yo-yos and I'm adding 1. It gives me 6. Are those equivalent? Absolutely not. Okay? You guys go ahead and try number 11 and number 12. Pause and do them, please. Okay? Over here, I'm going to combine like terms. I got a z and a z. And then I have positive 8 and minus 3. I have the 2 zebras now. And then 8 minus 3 would give me plus 5. So yes, those are absolutely equivalent. Okay? This is absolutely no, right? Because you can't just flip the numbers on either side of the subtraction sign. You can't do it with subtraction or division. Now, if these were pluses, sure, those would be equivalent. But it doesn't work that way for subtraction. Okay? I'm going to skip those two. This is where it gets a little bit more fun, using the distributive property to expand these. Okay, so I've got to expand these using distributing. Okay, 2 times 4x would be 8x. 2 times 3 would be 6. Are they equal? Absolutely they are. Now, just so you guys know this, you could do it the other way. You could factor it and do it that way. So you could find the GCF of 8 and 6 and get 2. And then what would you multiply 2 times to get to 8x? Hopefully you're saying 4x. And then 2 times what would be 6 would be 3. And there you can see that's the same as that was originally. So you can do it either way here. Doesn't matter. I personally think it's a lot easier to expand because you distribute it through. It's a lot easier than having to do the GCF and all that. Okay, so I'll do the same thing here. That's going to become 3y plus 18. Okay, are those the same? Absolutely yes, because of the commutative property of addition. Okay, let's expand this one. 5x minus 25. Are those the same? Clearly not. What mistake did they want you to make there? They wanted you to add 5 and 5 and get 10. That's where that came from. So those are not equivalent. They don't even give you the same expression. Here, distribute it through, expand it. It's going to be 4y minus 16. Is that the same as 16 minus 4y? Absolutely not. You cannot just flip the numbers when you're doing a subtraction problem. You guys go ahead and try 25 and 26. Okay? Okay, here we go. Do these last two and we'll be done. We got to distribute this. 3 times x will be 3x. Plus 3 times 5 is 15. Are those the same? Yes, of course they are. Because of the commutative property of addition. You can move them around. Again, 4 plus 3 equals 7. 3 plus 4 equals 7. Okay, here, let's distribute or expand. It's going to become 8y minus 12. Are those the same? No. You cannot just flip-flop subtraction. I know I'm repeating myself a lot, okay? So that's actually it for this learning target. So this is kind of it kind of just builds on itself. It builds up to getting all the way to the distributive property. So this kind of covered all the stuff we've done since learning target 5. This was 5, 6 all together. You just have to tell me if they're equivalent or not, okay? I'll see you guys.